So let's get into vapor pressure. First, I want to explain you what vapor pressure actually is, why do we test it, and then how it works and how it's implemented with our VP vision of Graphical instruments. So what you see here on this picture is basically a representation of vapor pressure. The definition of vapor pressure is, or vapor pressure actually starts in an enclosed system by the vapors over a liquid. So basically the liquid evaporates and the molecules of the liquid are getting out into the gas phase. Of course, molecules of the liquid are also getting back into the liquid phase, but at a certain point there is an equilibrium. The level of the liquid is no longer changing, and the equilibrium pressure, which is built up here, is the vapor pressure of the liquid. Typically, it's not the liquid alone, because maybe there are dissolved gases in the liquid which then add to this. We come to this later. Also, what the pictures show down here is that the vapor pressure is, of course, a function of the temperature. So at lower temperatures, you have less movement of the molecules, so the vapor pressure is less. If you go to higher elevated temperatures, the movement of the molecules is much stronger, and subsequently the vapor pressure that builds up in a confined space is also lower. That's important to understand, because that's why we have vapor pressure regulations which are differing from summer to winter, especially if you have cold and hot seasons. The vapor pressure in cold seasons, the standard vapor pressure of a gasoline can be adjusted much higher than the vapor pressure you can adjust during a hot season, because at hot season you need to put less volatile components into your gasoline. Why do people test vapor pressure? Well, there are three main reasons. One of the key reasons where it started are regulations. Regulations have two sub-reasons. First, you want to avoid pollution, so that's why there are environmental standards published by the EPA, CARB, or Euro. We all know the Euro 5, Euro 6 standards. Then we have, of course, also technical reasons, because if you have too high vapor pressure, when you transport gasolines through a pipe, it can result in a vapor lock, which means that instead of sending around liquids, suddenly bubbles start up, and you are producing gas instead of transporting liquids. Of course, if you have a cold season, then you want to have a higher vapor pressure, otherwise you would have cold start problems with your engine. And then one of the biggest problems is the problem of cavitation, especially when you do pumps in pipelines and so on. The cavitation is also a function of the vapor pressure. A high vapor pressure results in bubbles forming, and these bubbles can, when the vapor pressure or the surrounding pressure is reduced, implode, and this implosion can make a problem on mechanical parts of pumps. A big reason for testing vapor pressure is also safety. Safety for transportation, and what you can see here is one of these gun trails. That's something which happened early in the time when fracking has started in Northern America. And the knowledge about the high vapor pressure of the crude oil was not that good at this time. And then the tanks exploded and caught fire, and of course were causing a lot of injuries. Similar things to storage tanks, of course. And then, of course, you have the reason of profit. Butane blending or C4 blending is something which is widely done to basically adjust the vapor pressure of a gasoline to the limit. For example, as I mentioned, summer limit of vapor pressure is lower, winter plants have higher vapor pressure limits. And if you consider butane has just half the price. 1 liter of butane has just half the price compared to 1 liter of gasoline. You can really make a lot of profit by blending in the butane into the gasoline, and it mixes very fine, and also the heat of combustion is the same. Also, there are regional blends because there are locations in high altitudes, low altitudes that have different surrounding pressures, and also there you can fine-tune and fine-adjust the vapor pressure of your gasoline. How is vapor pressure tested, and a little bit the history. The classical test was the reed pump. So basically you filled your gasoline or crude oil or whatever you tested vapor pressure into a pump. You basically filled it just the lower part, and the upper part was empty. So to allow actually the gases, the air, which are dissolved in the vapor pressure to extend. And then you had put it into a water bath at 100 Fahrenheit to really get to the equilibrium. So that's how the vapor pressure was tested. And then Grabner came with 5191 method. This is the first instrument from Grabner instruments that really made the similar way of the reed method, just instead of having 250 milliliter bombs, just an automated chamber of 5 milliliters. And the big invention of Grabner instruments was then a new standard, the triple expansion. And I explained this on the next slide, why this was such a good idea. It avoids sample preparation. And then basically no new standards have been necessary, but we have came out with different generations of our vapor pressure testers. So now a little bit theory, and I hope you can all follow me a little bit. I have mentioned the 5191 standard, which gives you the dry vapor pressure equivalent. And the dry vapor pressure equivalent is basically the total pressure which is measured in a closed chamber with 1 milliliter of liquid and about 4 milliliter of vapor space, and it subtracts a number of roughly 4 kPa. It's 3.78, but why is this number subtracted? This number is subtracted because this vapor pressure which we see here is not only coming from the sample. This vapor pressure is also containing a little bit a portion of air molecules which were actually dissolved in the sample before. We call this air portion P gas. Yeah? And this P gas cannot be measured with just a single measurement like it was with 5191 or the old reed method. So what Grabner came out with is he introduced the triple expansion, and he has measured the vapor pressure at 3 different expansions, and thus he could actually really measure the contribution of the dissolved air which was in there. And thus they could measure for the first time really the absolute vapor pressure of the liquid. For the 5191 and older vapor pressure standard, to make sure that this factor here, this 4, is relatively constant, you always had to do an air saturation of your sample at 0 degrees centigrade to make sure that you have a constant amount of air dissolved in there. But this is, of course, a little bit the problem if you have different ambient and barometric pressures. And thus, this triple expansion is a good invention because you don't care about how much air is dissolved because you can just measure it now. So a little bit about the theory. I have also in all the slides put together some of the graphical user interface. As I said, you just need to press the start button after having selected maybe a template. And then you see a graphic representation of what's going to happen. And finally, you get the result of your measurement, and also a nice graphical representation. Here you can nicely see the three steps of the three expansions. And you can also see the equilibrium, that is how long it takes to get basically the sample molecules into the gas phase. So just a summary, the Miniwap VPV is really now the latest generation, which is designed really to include all the methods. And to include all the methods, a shaker has been built in. It has really a very wide pressure range to also be able to run LPG samples without any pressure regulator. Consequently, you have also the possibility to really measure everything which is related to a vapor pressure standard. So 5191 up to the latest standards that we have. We have, of course, similar standards in international regions, IP standards. That's the latest triple expansion standard of the Energy Institute in UK. That's the latest version of the triple expansion of the EN ISO. And it's getting more and more into the fuel specification around the world. Here are just a couple of examples. I will just jump over them because I see we are getting ahead in time. Just to point out the high precision that we have, that the red bars here is the allowed precision by the standard, and this is small bars are where our instruments is measuring. Also, this one is just showing the very high pressure range, and this was basically a test of propane, pure propane, of which you have a theoretical value, and you see, especially at 100 Fahrenheit, there is very, very small deviation, if not no deviation, between theoretical and tested. So finally, integration and automation with the cockpit. Cockpit is basically the Windows software which is combining all the vision instruments of Graphical instruments. You can use it to consolidate the results from multiple locations in one central lab. You can deploy different standard operating procedures, user roles, and just from a single place, and make sure that every laboratory you are working with who has the same instrument is using exactly the same methods and naming convention, user roles conventions, and so on. You can also check the calibration and calibration history of every instrument. You can configure and provide support to the Miniwap VP Vision and also the FP Vision, which I didn't mention here. And I've mentioned also SQC and GLP compliance according to D6299, which I will show you a few screenshots on it. That's the general screenshot of the Windows software. Basically, on this side, you have all the different kinds of instruments that are connected to it. Instruments which are online shown here with a green light. I hope you can see this a little bit on your screen. Instruments which are offline have basically a red light here. You can then select the instrument, it opens a tab, and then you have different things you can do with an instrument. Also, for example, service, calibration, device configuration, and so on can be done. And then in each section, you have a couple of other things you can do. It's very, very intuitive when you look at this. A cool feature of this is also that you can basically select a group of instruments in one go. So you see here several instruments are selected, and then you can basically compare of these instruments, for example, the measurement results across different instruments, but you can also do the device configuration of these different instruments. So if you are setting up users or certain standard operating procedures, you can do this once and send it to all the instruments which you are selecting here in one go. So you don't need to go to every individual instruments. Compliance with good laboratory practice and statistical quality control standards. That's especially mandated for the vapor pressure testers and other physical property tests, and is important for audits, is important for the quality assurance in bigger companies to prove the reliability and the performance of the equipment. And also the Environmental Protection Agency and the Ministry of Energy and other similar organizations require that a quality assurance can be traceable for the instruments. And that's very important. And we are complying with this. You cannot delete this quality assurance results, and it's stored for 5 years. So this is just a screenshot showing you one of these different plots. There are a lot of different things you can do, and in full compliance with this ASTM SQC standard, you have I charts, MR charts, you can do normal probability charts, and this for any of the connected VP visions or FP visions, no matter where these instruments actually are. So a quality control manager, quality assurance manager can be in a central location and basically on a routine basis run through all the instruments which are distributed in separate labs, and he does not need to fly there physically and check them. This cockpit software allows you also to deploy enterprise solutions. Why? Because this cockpit is basically working and synchronizing the data from each individual instrument with a database. This database can be on individually, local, on a PC if you want it, but, and this is how we implemented it at Grabner Instruments, and bigger companies are implementing it, you can connect it to a standard database server. And this can be a MySQL, SQL server, Oracle server, or IBM DB server, whatever. It's working according to database standards. You just need to have a data source name string, and then you can connect it. The device database, so there's also a small database on the device, is then synchronizing here with the data with this, and with every computer you can access either the data from all the devices or here the individual instruments. We are also supporting automation. Automation is supported by implementing generic XYZ samplers. Instead of making our own autosampler, which we have, the Run 12 is one autosampler which we built ourselves for the VPX Vision, the earlier version of our vapor pressure tester. We decided to really support generic autosamplers. What you see here is a Perkin-Elmer S10 autosampler, which we have currently tested, and it's working quite nicely. This one allows you to go up to, I think, 48 of these kind of samples, about 12 of the standard 250 milliliter samples, or about 6 of the 1 liter bottles, which are required by some standards. And it's nicely integrated and operated directly from the instrument. And the setup of an autosampler is also quite easy, because what we use is again the cockpit, and we use so-called playlists. These playlists can be then sent over to an instrument. This is the instrument section, and this template is really looking to use different type of standard operating procedures. For example, you can select which method to use for a certain position, and then it has 2 more or 3 more special procedures: a waiting procedure, a cleaning or bake-out procedure, and a rinsing procedure. And you can individually adjust, of course, for each different position what you want to do. Here I have an example of 4 positions which we have defined. Of course, this list can go as long as you have positions available, and you can decide how many measurement cycles on each position needs to be done. We have here rinsing cycles, a waiting cycle we have implemented, and then another measurement. You can really modify all these playlists here. You send it over to the instrument, and then on the instrument it looks like this. So here you select them just here from this drop down, the playlist 1, And if everything is set up, you just need to press the play button. The playlist itself can be, of course, modified and adjusted here on the device itself. And yeah, if you need to change it or save it when you have done changes, you can do this also from the device. So you don't need to have the Windows software always connected or go through the Windows software. Also, the device works fully as a standalone. Have a great weekend. Thank you for participation.